So how are we doing today? I hope you're having a great day. I will be talking to you today a little bit. Well, we're going to break section 8.2 into two parts. And what we're going to learn is, well, how do I move these things around? How do I translate? This first part here is how do I translate? So you'll be able to take a parent function, learn what that is, and move it left, right, up, down, flip it in the x-axis, so forth and so on. Using E as a base, what we're really going to focus on is compound interest and how compound interest works. Uh, Basically, also that goes into this is we'll be talking about half-lives and all that good stuff. So basically, today we'll cover the translations and the half-lives, and tomorrow we'll talk about compound interest. Okay? So I'm going to get started here. This one right here is not in your notepad. So all you need to do is just take a peek at this thing. Um, what we're talking about is if I have a graph, which we know how to graph now. So we're going to graph one of these. We can plot this guy. Actually, I should circle that in red because I have it marked in red. So let's go ahead and circle this guy in red. Here's your red graph. All right. So if I started there, I'm typically going to start with x equals 0, just because that's nice, right? I find my y-intercept, which I should know at this point. My y-intercept is this number right here, which is 3. So I get 0, 3, plot the point, and then we work from there. Okay, basically, this 2 here means this is a doubling function. In other words, every time my exponent increases by 1, my value doubles. Okay, and the 3 is just a multiplier out front. Okay, so now, so if x is 1, y is 6, x is 2, you guys can plot these in 324. Nothing too interesting over there. No big deal. Where it gets interesting is over on the as x gets smaller. Okay, when x gets to be -1. Okay, so 3 times 2 x to the -1. So I put -1 in that exponent spot. Okay, we all know from our work with exponents that that's 3 over um, 2 to the first, right? So that's 1 1/2. That gets us this number right there. So those numbers, as you can see, 3, 6, 12, and 24 was doubling. If I think going the other direction, I'm taking half each time. So 1 1/2, 3/4, 3/8, and so forth. So you can see really quickly this gets very small. By this, I mean the y value coming out of the function. Okay. But what you're going to notice is, and if you think about it, it makes sense. Nothing is ever going to happen where this red line is going to touch or cross the x-axis. Okay. So what we have is called an asymptote. And we're going to be identifying the asymptote. Asymptote is the hug line. Okay. So the hug line is at y equals 0. Okay, so we're going to be identifying asymptotes as we go through this process here. Okay, all right. Now, for the blue graph, it's pretty simple. All that happens is everything is the same except this negative right here. We should know at this point that that's going to flip our picture in the x-axis. It's going to basically make a smile into a frown. Okay, so we're going to have the exact same thing going the other direction. If x is 0, and again, I'd start right here. If x is 0, y is -3, and quickly and easily we can plot some points and get that going. All right? Okay, let's move into the family of functions. So basically, if we've got b to the x, we're not focused on the y-intercept, right? The a is the y-intercept right now. Not focused on that. But if I'm changing the number right next to the exponent, I have a new family, okay? If I'm changing this number, this b, the number right next to the exponent, I have a new family, okay? Fair enough, and that's just for our purposes of categorizing these families. All right, and let's see how this works here. Let's lock this in, make this a little bit smaller. And basically, the things that we, for example, 2 to the x is shown here in the picture. Okay, 2 to the x. So a doubling function. If a is in effect 1, so I get this, and then every time x increases by 1, my value doubles. So you get 1, 2, 4, and 8. Okay? So now if I think about this, my domain, x could be anything, right? X could be anything, all real. And the range, well, y has to be greater than or equal to 0 because the asymptote, the hug line, is at y equals 0. Okay? Now let's look down here at the bottom here quickly. Basically, so if I were going to graph one of these functions in this box here, I would start by graphing 2 to the x. Okay? Start by graphing 2 to the x, because then the rest of our rules, what you would think as far as what we did with any sort of parabolas. Last week we did this with rational expressions. All this stuff stays the same. In other words, this plus 3 out on the side moves my function 3 up. The negative 6 moves me 6 down. If I'm next to the x, okay, that's been a counter move, so that's 2 to the right, just like it's been all year. Okay, this is 1 to the left. Okay, this makes me stretch, makes me skinny. This makes this wide. The whole number makes it stretch, and the half makes it wide. And again, if you plug in some numbers there, these are these guys right here, the stretch and the compression. If you plug in a couple points, that's how you see that. Okay. The reflection down here, we already talked about that. Across the x-axis is changing this, and across the y-axis is making that uh, negative. Okay? Basically, this guide, we're just going to focus on the biggies, and we're going to move a couple of these. So basically, in your guided notes, now you're in your guided notes, you have this guy right here. Let's go ahead and pull him out of there. Okay, so basically, if I wanted to graph this, okay, in other words, I know I have a right 3 and a down 2 in there, I'm going to go ahead and start by graphing this guy. Take away all the moves, and what do I have? Okay, so basically, if you make a little t-chart, you can say, okay, and it doesn't have to be a lot of points. It can go real quick. If x is 0, if x is 0, y is, see, 6 times 1, so 6, plot the point. If x is 1, okay, 1/2 times 6 is 3, plot the point. So I can see this is a half function, right? Half-life, it's decaying, if you will. And if x is 2, y is 1.5 or 3/2, so forth and so on. So it's becoming half every time. Okay, so when I get to 3, that'll be 3/4, so forth and so on. So my original picture in blue here, this is going to be this decay function, the original function, just like that. And it's going to be, I'm still going to have an asymptote at y equals 0. Okay, at y equals 0. All right. So now, what we just talked about already, we've got this in the notes here. The h is 3 and the k is -2. So we went 3 to the right and 2 units down. Okay. So now, when I do that with that picture, all I need to do is, if I want a red graph, all I need to do is pick a point, really, and move him 3 right and 2 down. So I can take all the points. 3 to the right and 2 down. So forth and so on. 3 to the right, 1, 2, 3, and 2 down, 1, 2, little estimate there. So my new curve looks like this. And where's he going to hug? He's going to hug, um, the new hug line is going to be right down here. Since I moved everything down to y equals -2 is my new hug line. Okay? All right, and that's how we're going to graph these. In this next section, they're asking you to graph. And again, all I really want you to do for right now, just a quick and easy, is I'm going to say, let's say, well, how did this thing move from the parent function? Well, this guy, this first guy in the A, I have a +1 there, so you should just have right here, real quick, a left 1. Okay, so you'd graph the tripling function here, and then you would go ahead and take your points and move them all to the left 1. This one, you would take that original function, so part B, you'd come in here and you'd say, okay, this is down 4. And you would move everything in your picture down 4 units. So the asymptote for this guy is going to be at y equals -4. Okay, asymptote of this guy back here in A is going to be y equals 0 again. Okay, all right, this last one here, this one, there's two things going on. I went right 3 and I went down 1, so my new asymptote should be at y equals -1 on part C. All right, and that's really our conversation. That's going to be our conversation about translation. So we're going to go ahead and move into, actually for Half-Life, we're going to have to break this into two parts. So I'll go ahead and stop this, and we'll go into the second part.